Hello the internet and welcome back to my channel. On the bench today I have a MacBook, and judging from the model number at the back, this should be something in between 2006 and 2009. It should be an Intel Core Duo or Core 2 Duo, one of those. I've been sent this laptop by two of my friends. Hello Marco, hello Antonella from France, and they got in touch with me and they basically mentioned they had this laptop which is working but is shutting down after something between 30 seconds and 5 minutes, and they asked me if I could have a look, and I thought, yeah, that's probably an easy one. It's probably just overheating and it just needs a repaste, a good service, a good clean, and it's gonna be fine. However, there's a little plot twist because when I received this laptop, it came to me in a box with no packing material at all, and I got in touch with them saying, hey, that's not how you ship a laptop abroad, but they looked at my pictures and they said, no, we didn't ship it like that. We had plenty of packing material, so I can only assume that either the French or the British customs decided to open the parcel, inspect the computer, and then they decided the packing material was not necessary anymore. Well, the problem is that this laptop now is not working anymore, so it's not just a matter of overheating or whatever that was a problem, it's just not working at all. So that's what we're gonna do in this video. So let's not waste any more time. Let me thank today's sponsor, PCBWay, and let me show you what the problem is with this laptop. Alright, so the laptop is not in too bad shape, though here at the back I don't know what happened to the battery door. The plastic has degraded, there's some tape, so we might need to take a look. The feet here are completely disintegrated, and let's have a look at the keyboard and the screen. Okay, well, it's okay, it's well used. But it's actually in very good shape. I think once it's nice and cleaned, it's going to be okay. I believe the screen might need to be replaced. At least that's what Marco said. It kind of works. I'll show you in a sec. This has been off for many months, so I'm sure it will need a charger, which is one of these MagSafe ones. There we go. Now I got a green light, which, green and then orange. I believe it means it's charging, so that means there are no shorts or anything. Now let me try and turn it on now. Dead. Well, I'm not sure whether it might need a little bit of charge. I doubt it. But months ago when I tested, it was actually doing something. It was showing a white screen. But now it looks completely dead. Well, I didn't do anything. I heard the CD-ROM making noise, and we had a bong. And you can't probably see it, but there is backlight, and that's it. I guess it's actually gray screen. It's taking a little bit of time to come back to life. I guess is this like a LED or CCFL type of screen? Oh yeah, no, actually, it is working. I didn't get that last time. It was a white screen. So now it's saying there's no hard drive. I think if I'm not a Mac person, though recently I've got a Mac Mini for editing, so I'm learning my way through the hoops of Mac OS. But that to me means the hard drive is not connected, it's not working or whatever. Let me try just and turn it off and on again. It's definitely working, so it needed a little bit of charge. It was completely dead, kind of unexpected. Let's try again. And this time I got a gray screen, though I can't hear a spinning drive spinning. So I would say let's take a look at the hard drive. I have a feeling that that's probably the only reason why this thing is not starting. The hard drive got damaged in transit. That's why it's getting stuck at this point. Maybe once the hard drive is working and the OS is reinstalled, it will probably do what my friend said, is just shutting down after a few minutes. There we go. No, it's actually starting now. Oh yes, the hard drive has started. It's just a bad hard drive. I guess this has been through a tumble without packing material, and the hard drive is just struggling to start, which is freezing the whole machine basically. And it's been a while and the OS doesn't want to start. So let's open it up and let's have a look at that hard drive. I just might need to replace it. And I've removed the hard drive and the machine more or less goes immediately into the question mark. So I guess that this is faulty. I'll plug it into my dock on my Windows machine and see what my hard drive analyzing software is saying about the hard drive. Meanwhile, before I go ahead and try and reinstall the latest operating system for this machine, which I understand is 10.7, I'd like to open it up and take a look, just in case maybe, for example, the fan is not working at all. There's no point because the operating system will not install. So let's open this machine. You went away. Let's open this machine and see what we find inside. Well, actually, the machine just shut down. While I was talking, when I said it went away, it actually shut down and is now, or at least it was, refusing to turn on again. Yeah, it's not turning on anymore. Let's open it up and see what's inside. Okay, well, we're inside and the fan is definitely spinning, so it's not like a mechanical thing. Now I'm wondering whether maybe there's not enough thermal paste. Let me try and power this up without the keyboard, but I have a feeling this needs the battery in. Because I have a green light here. Well, obviously, no, I do need a keyboard, of course. That's I need to power it up. Alright, I've got a better setup here. I just removed some tape so I can install the keyboard this way. Let me apply some power here and push the on-off button. Look carefully at what the fan is doing. So if I turn it on, the fan is trying to do something, okay? But it's not spinning. But sometimes fans, especially on Apple computers, they don't spin straight away. They just try and keep the computer as quiet as possible. But from here, I can see something that probably you can't see from the overhead camera. Let me use my mobile. I'll show you. So your computer is now on the question mark. And let me see if I can show you something here. Do you see what I mean? There is a small screw inside the fan. And that's why the fan is not spinning. And that's why the computer is overheating. Amazing. Let's remove the screw. And if you like this video so far, well, maybe it's the right time to hit the like button, leave a comment, or even subscribe to this channel. Making these videos is fun, but it takes me absolutely forever. So any kind of feedback from my audience is always good for my motivation and my self-esteem. And don't forget, I'm on Patreon as well. There's a free tier, so if you could support me on Patreon, that would be absolutely fantastic. And speaking of supporting this channel, well, let me thank PCBWay for sponsoring this video. PCBWay is a global manufacturer for PCBs, 3D prints, metal sheet fabrication and CNC machining, so any kind of projects you might have, well, PCBWay is your stop. You can find plenty of free projects online, which you can then upload on PCBWay.com, whether it's a PCB or a 3D print, for example. The process is more or less automatic. Just select the color of your PCB or the color of your 3D prints, select a postal service, and PCBWay will deliver your items at your place. I've been using PCBWay for all my projects. I've recently ordered some 3D prints which are absolutely amazing, and I'm really happy with the service, so I'm happy to recommend it to you. Take a look at PCBWay.com, the link is also down below in the description, and let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with the MacBook. Right, the fan is still having the same behavior, and I can see the heatsink as it's about 82 degrees, so I think I'd expect the fan to run a little at this stage, and most importantly, the question mark on screen eventually will disappear because the CPU will protect itself. So we either have a faulty fan, and I'm hoping that's the case, or we have something wrong with the fan controller. But we need to fix that before doing anything else. Alright, before rushing to buy a new fan, I decided to turn on the oscilloscope and have a look at this connector. It's a 4-pins connector. I found the schematics for this machine, if I'm not mistaken, and I can see the pin 1 is 5 volts for the fan. Then we have the tachometer, which is speed back from the fan itself. Then we have motor control, which is the PWM signal going to the fan, and then finally we have ground. I've got the oscilloscope running. That interference, I guess, is the power supply. I have no idea what that is. Probably my long ground lead. And if I turn this on, I'm scoping the 5 volts, so I'm expecting 5 volts. And there it is. We got 5.02 volts. So the fan is being properly energized. The next one is the tachometer. And the tachometer is not saying anything because the fan is not spinning. And I suspect that if I spin the fan, I might be able to see something on the oscilloscope. So you see the tachometer is working, but when it comes to the PWM signal that goes to the fan, it's not doing much. It's more or less stuck at 5 volts, 4.8, and it's not switching. That's supposed to switch. It's doing a little something, which is probably the reason why the fan is doing a little bit of movement, but it's not really switching. So it sounds like this is not a fan issue, but a control issue from the board, which is disappointing because I guess we need to take out the board and start inspecting things. Looking at the schematics, the motor control pin, which is pin number 3, is driven by the SMC, which I believe is the chip looking after all the temperatures and fans and sensors on this machine. And the signal is called SMC Fan 1 CTL. It's going through a MOSFET Q560, and then it becomes Fan RT PWM, which is the motor control pin itself. The MOSFET is also getting 3.3 volts from a line called PP3V3, and I believe the PP3V3 is working because we have a tachometer signal out if we spin the fan, and that also relies on the same voltage. We can double check, but I have a feeling that that is definitely there. So the next step would be to check whether we have a signal going into the MOSFET to drive the MOSFET and then drive the fan itself. This is where the board view becomes really important. J5601 is the fan connector, and Q560 is just adjacent to it. And bear in mind that the board is like the other way around. Compared to the board view, it might be a bit confusing, but this little thing here is the chip I'm looking for, which is Q5560. And if I'm looking at this pad here, it's Fan RT PWM, which is the fan controller going to the fan itself. What I'm going to do now, I'm going to check whether the pin 2 of this IC, which is SMC Fan 1 CTL, has any signal on it. If there's no signal there, obviously there won't be any signal at the fan controlling pin. And according to the board view, if this is the fan connector, well, this little guy here is the MOSFET in question that we want to check. And this is why I don't normally do modern stuff on this channel. I got lots of comments and also some of my friends saying, why don't you try and repair more modern stuff? You might get a wider audience. And the reason is exactly this. Everything is so small. I haven't got tools for them. This is the smallest probe I have for my multimeter. As you can see, yes, I might be able to check these IC, but you know, it's not great. Even my oscilloscope, I believe, is more or less a similar size. Actually, it's bigger than my multimeter probe. I do have some nice probes, which are from ProbeMaster. I might review them at some point. I was given them by a good friend of mine. You know who you are. Thank you for that. And these are actually better. They are a bit more pointy. So what I think I'm going to do, I'm going to do a little bit of bodge work, and apologies for that. I'm going to have an extension from my oscilloscope tip to this ProbeMaster tip, and that might introduce some noise because obviously I'm using extensions for everything. But at this stage, we are not looking for cleaner or clean signals. We are looking for signals. So whether it's there or not, it doesn't matter whether we have some extensions. So give me a sec, and I'll come up with a little bodge work here. I believe I'm probing the control signal coming from the SMC. So let's try and turn on the MacBook now. Oh, and there is a 3.3 volts line coming with no control pulses whatsoever, which is eventually what I see on pin number 3. So that's not good. It looks like the SMC is not controlling the fan. Now let's try the other pin here. Let's turn it on. 3, 2, 1, go. And this should be the 3.3 volts coming to the MOSFET. And obviously as the output here, yeah, obviously I've got, why do I have 5 volts as an output? That's kind of weird. I believe I saw some switching at some point. That was weird. Now, one option is that the fan is faulty and is somehow crippling the controlling signal. So let's remove the fan connector again, and let's check before the MOSFET. 3, 2, 1, go. And no, we only have 3.3 volts, and this should be coming from the SMC. Now, unfortunately, from the schematics, that signal coming into the MOSFET is coming directly from the SMC. So there is a chance that the SMC is not working, or hopefully the MOSFET is not working, is shorted. Let's check it with the multimeter. Now, checking MOSFETs is not like checking transistors. It's a bit more complicated. There's a little procedure to do that. And this is in circuit. So I don't think that that's going to work. So first thing first, let's check whether we have like a dead short. And that would definitely mean that the MOSFET is faulty. No, there isn't a direct short. I don't see anything wrong with it, but I'm not entirely sure. But while I'm looking with the microscope, everything is obviously very much magnified with this thing. But I do see signs of corrosion on this board. I see some green stuff here, so maybe I should take the board out, have a good inspection under the microscope, and maybe give it a good clean, and maybe resolder whatever I can resolder, because there's clearly some corrosion here. Now, before we do that, if I remember right, the Macs have a sequence of keys to reset the SMC. And again, it's worth trying before starting removing components and removing boards and stuff. That should be an easy test. And apparently I need to press Shift, Control, Option, and Power. And I believe when I release these buttons, the MacBook starts up. It does. Perfect. Has the fan started working? No. Now, before I start thinking of removing the board, because then I guess it becomes difficult to try and power it up again because everything is disconnected, I think I'd like to remove that MOSFET and see if by any chance with the MOSFET removed, I have a signal coming from the SMC. That would tell me that the MOSFET is faulty. Three, two, one, go. Oh. 3, 2, 1, go. Dead. And no, the MacBook doesn't turn on anymore, so I'm assuming that that MOSFET is somehow being sensed and the SMC doesn't like to start the computer without it. Or something else happened. I have no idea. And no, it was just the battery probably not properly seated. And unfortunately, I haven't got any signal whatsoever coming from the SMC. Nothing at all. What is puzzling me a bit is that I still get the 5 volts coming from the fan. So maybe the SMC is just grounding that signal to create the square wave required to spin the fan. Now, before I invest too much time on that logic board, I really would like to make sure that this fan is actually working. Now, this is a 5 volts PWM fan. I haven't got another one, not even bigger, just for a quick test. And I only have 12 volts PWM fans, like this Intel cooling fan here. I can still run some tests. The first one I'd like to do is what happens to a PWM fan when you only supply the voltage, but no motor control, no PWM signal. So this Intel fan is currently connected to my bench power supply and it's only got voltage coming in, 12 volts and ground. And I put a little bit of masking tape here so you can see the rotation a bit better. Let me turn on my bench power supply and see what happens. In 3, 2, 1, go. And the fan is spinning. Whether it's spinning at full speed or not, I'm not entirely sure, but it's definitely spinning. So that's definitely a test that we can do with this fan as well. Now, I don't have a PWM controller that I can use with this fan, besides wiring it back to this motherboard, but I'd like to do a quick test. I have a signal generator which can output a square wave, and I'm curious to see what happens when I'm changing the frequency or maybe the amplitude. I'm not sure. I'm curious to see whether the signal generator can somehow be used to control a PWM fan. And then if that works, I can try that same method on this fan as well. So let's give it a go. So I've connected my signal generator to the blue wire, which is the PWM signal, and I've got the oscilloscope on screen, which is monitoring that line. So you see what happens. I'll put the microphone close to the fan so you can hear whether it's spinning faster or slower, because I guess you won't be able to see that from the camera. As you can see, there is some sort of control using the signal generator. Obviously, it's not what the fan is expecting. The fan is expecting the duty cycle to change, not the frequency. And I guess by increasing and decreasing the frequency from the logic perspective of the fan, well, the duty cycle is also changing, and that's why the speed is changing. But, I have some sort of crude speed control through my signal generator. Now, let's try and do the same with the Apple MacBook fan. I've wired just the ground and 5 volts to this fan. Let's power up my bench power supply, which is set to a maximum of 360 milliamps, and see what happens. 3, 2, 1, go. And as you can see, the fan is basically doing what it was doing on the board. So every 5 seconds or so, it tries to spin. So this is already a good indication that probably the fan is faulty. I can see the power supply is going to 300 milliamps, which is what this fan should draw. It's maximum 350 milliamps. So assuming that this fan is behaving like a normal PWM fan, it's an Apple product, so you never know. This is already telling me that maybe the fan is faulty. I've now wired my signal generator to the motor control pin. Let's give 5 volts to this fan and see what happens. Well, surprisingly, I found a frequency which can make the fan spin a little bit. It's 11 Hertz, but I don't think this qualifies as a spinning fan. I think this is just a glimpse of rotation, as we've always seen with this fan. It happens at the right speed that it keeps spinning a little bit, and it looks like the fan is spinning a bit. As soon as I move away from that frequency, this stops working again. So I don't know. I'm not entirely sure how these fans are working on an Apple machine, but I think I got enough clues to just would like and order a new one, a replacement one. Now, I know what you're thinking, why don't I see the PWM signal coming from the logic board? There must be a fault with the logic board as well. Well, that is a possibility, but I have an idea. And the idea is that the motherboard maybe is controlling the PWM signal of this fan by pulling it low to ground to make the appropriate duty cycle to spin the fan. Now, when you turn on a computer, the fan is off. So I'm assuming the MacBook is trying to push the fan at maximum speed for a moment, and is expecting some kind of tachometer signal coming back to it, and then just slow it down and control it depending on temperature. Now, because the fan doesn't spin, there's no tachometer signal coming back, and maybe the SMC, what it's doing is just, it's asking the fan to spin, and that's why I see a straight 3.3 volts coming from the PWM signal of the SMC, which is telling the fan, hey fan, you need to spin. So let me get another one, and we'll try that before digging any further into the logic of that board. The replacement fan has arrived, and it's second-hand. Now, I wouldn't normally buy a second-hand fan because fans wear out, so I would buy them brand new. But with this model number, I could find a variety of fans of so many different shapes from so many different manufacturers. So I'm not sure whether they are all fake, or maybe this model number refers to the impeller, the motor inside, and then the same fan is being used by different manufacturers in different shapes and enclosures. I have no idea. Now, before I fit it into the MacBook, I'm actually curious to see whether this fan spins when it's been supplied with, say, 4 volts, and see if it spins without the PWM signal. So this is the fan that I removed. As you can see, it's doing what it was doing before, and this is the replacement fan. Yeah, it's working totally fine. It's drawing 200 milliamps. So yes, this fan is definitely faulty. Now, I'll give this fan a little clean because the seller just didn't bother to clean it a bit better. And then we'll fit it into the MacBook, and hopefully it's gonna work. Time to test. Will it work? Power to the power supply, and let's turn it on. 3, 2, 1, go. Yes, it's working. Amazing. Fan is working, screen is working, and MacBook is starting. And you won't be able to see it, but there is a question mark flashing on screen. I'm confident that the issue we were having, the MacBook shutting down, was the fan not working. Now, this logic board needs attention. There is corrosion and it's really, really dirty. Now, before I take it out, I'd like to make sure that everything works first, reinstall OS X, make sure everything works, and also check the temperatures out of curiosity. Then, once we know that everything is working, we'll disassemble the board, give it a good service, remove the oxidation, give it a good wash, put it back, new thermal paste, and we'll reassemble everything. Now, I'm not a massive Apple expert, but I understand that installing these old operating systems is not straightforward, mostly because some old installers, they have expired certificates that won't work if the date is set to 2025 as today. Let me find out what's the best way to reinstall this machine. Let me also source an SSD drive. Obviously, we're not going to reinstall a mechanical drive. And then I'll set up the camera so you can actually see the screen, and we'll go ahead and reinstall OS X, I think it's Lion 10.7.5. Installing Lion 10.7.5 was simpler than I thought. Thanks to a community script found on Macrumors, linked below, it was just a matter of downloading a file and running the script on my Apple Mac Mini on macOS 15, aka Sequoia. The script crashed at first, but it turned out to be a USB hub issue. Using a different USB hub solved the issue and the script completed successfully. I then plugged the USB stick on the MacBook and it booted onto the OS X installation program, not before attempting to run Windows from the random SSD I used for the test, as I confirmed that the original mechanical hard disk was dead even on my Windows machine. The system turned out to be running totally fine, though, as expected, the fan would run pretty loud pretty easily, probably due to dry thermal paste. The DVD drive seems to have some issues. A disk I tried to read seemed to be unable to slide in, and when it finally did, the drive produced some nasty noises. And then refused to eject the disk at all. We'll take a look in a minute, but now it's time to disassemble this laptop and take care of the dirt and the corrosion. Disassembling laptops is always a pain, and this is no exception. Surprisingly, this MacBook had so many different screws of different sizes and shapes. Of course, I did not take note of what went where, otherwise, where's the fun? It took me a while of poking and prying to eventually get the board out. Meanwhile though, I removed the heatsink and, as expected, the thermal paste was very dry, so applying some fresh one should help a lot. The logic board is finally out. I also removed the DVD drive as it was making some nasty noises before, and I wanted to take a look and see if there was anything I could do for it. Logic board is out. It's not too bad, though I definitely see some areas which need a little bit of attention. But most importantly, I see something inside the RAM slots, the RAM connectors. I don't understand what that is. I'm not sure what that is. It looks like maybe thermal paste or some sort of mold or corrosion or growth. Besides that, I don't see any major damage. This board will need a good wash in my PCB cleaning fluid. I'll show you in a second. But right now, let's take a look under the microscope because I'm curious to see what's happening inside those RAM connectors. Now, the good news is that I don't see any issues with the connectors. Those would be a problem if they get corroded or damaged by corrosion. But whenever you see blue stuff on a PCB, well, that's definitely some sort of corrosion. And unfortunately, it's not just limited to this part, which obviously is not a big deal. I see some blue/green particles here. Now, thankfully, this is not BGA, I think. So I can just reflow it a bit and clean it, and hopefully that will sort it out. Same around these two components. These on the left-hand side is the CPU, and this connector is thankfully unpopulated, but it's never nice to have corrosion on anything, and well, thankfully, obviously, that didn't prevent the computer from working, but that will need to go. That component will also need to be reflowed, and this connector also will need some attention. This happens to be the RAM connection, by the way, so I'm even more surprised that this computer was doing anything at all, and we'll take a look inside the connector in a second. This is the battery connector. Again, I see some blue stuff in here. I think this can be removed. But thankfully the rest of the connector is totally fine. Now, let's get to the RAM connector. What is that white stuff? I have no idea. It looks fluffy to me, so I'm not entirely sure that that is thermal paste. Well, in any case, we need to take care of that corrosion, that blue stuff, and then we need to wash this board. Well, the funny thing is that the RAM seems to be completely unaffected. I don't see any deposit of that white stuff anywhere here. How come? When I watch some videos from Rossman or Northwest Repairs, it always feels so easy when they work on components on motherboards or GPUs. Everything just solders magically. The truth is that it's not easy at all. These are multi-layer boards with large ground and power planes. I'm starting with the smaller tip I have, but it doesn't have the required thermal mass to do anything. So I switched to a bigger one, but it still struggled to do anything. Also, we have corrosion here, which is like soldering on concrete. Eventually, I see the solder melting and becoming shiny, but I'm not sure how effective that was. This capacitor is another example. Solder just refuses to melt because of ground and power planes and corrosion. Only when I apply some mechanical action to remove the corrosion, then am I able to reflow the joint. I'm using an engraver tool here, which feels a bit too rough, and you'll see what I mean in a minute. These pads have some heavy corrosion going on, and it's always nice to see the vinegar, which is an acid, fighting the damage. The RAM connection shows the same behavior. It takes a while for the solder to reflow where that nasty corrosion was. But in the end, I think it came up okay. Now it's the turn for this corroded component. I use the engraver tool, but this is a 0402 component. It's smaller than small, and the tool was a bit too aggressive on it and it chipped both the capacitor and the resistor. The resistor in particular just refused to accept solder. I kept trying and trying, without the engraver now, but it wouldn't help. Only at some point, while scraping, a hidden pocket of rust came out of the joint, and then the solder finally melted. I should probably replace these components as they look damaged, but I don't have a big stash of S&D parts, definitely not of this tiny size. It's now time to wash the whole thing in my favorite PCB cleaning fluid, Electrolube Swash. It's water-based and designed for PCBs, It's great at removing oxidation, so that should help with anything I haven't been able to reach. Now it's time to take a look at the DVD drive. I managed to open it and take a look, but it's basically impossible to disassemble, and I'm concerned that if I did, I struggle to put it back together. Also, it's difficult to test while open, as the connector is not a standard SATA and I would need to use this very laptop to test it. So I decided to remove the dust, clean and lubricate the worm screw driving the head, and clean the head with isopropyl. I didn't realize my ceramic screwdriver could scratch copper. And anyways, there is some residue on one of the heatsinks, which turned out to be part of that corrosion we saw before. So I wet lapped the surfaces with some very fine sandpaper, I think 4000 grit or whereabouts, and I think it came out okay. This is when things got challenging. I went to power up the Mac, the fan spun up, but it was dead. No picture, nothing. What could have possibly happened? I started poking around with my multimeter, probing the large inductors. Those are often located on the main rails. I could read 1.5, 1.8, 1 volt, but on those inductors at the top, I had nothing. A quick look at the schematics revealed that those inductors should carry the V-core for the CPU, so no wonder the laptop is dead. But why? Which one of the 1000 components is responsible for that? Without thinking too much, I focused my attention at those two components I chipped earlier on, which happened to be nearby. The capacitor still reads 10 microfarad as it should. However, the resistor doesn't read 10 ohms anymore. It reads 10 ohm on the edge of the resistor, but not between the pads, so it's broken somewhere. That resistor is on the supply line for the buck converter for the V-core generation. Without that supply, there is no V-core. So I did what I should have done earlier on and ordered a replacement resistor and capacitor to replace the broken ones. Once replaced, I went to test and... yes! Panic over, it works again. And V-core now reads 1.11 volts. I really thought I had broken it for good. The next step is to replace the battery, which was on the low side. I'll save you the pain of watching me struggling to put this thing back together. Just know, it was a pain. When reassembled, I noticed the DVD was not working anymore, and a closer inspection revealed some rust and corrosion at the connector, which I tried to clean up. The DVD drive makes a horrible noise when loading discs. It seems that something is struggling mechanically inside. But it works. Is that supposed to make those noises? Leave a comment down below if you're familiar with that model. After reinstalling OS X on the new SSD I purchased for this machine, I decided to go ahead and replace the speakers because I don't think they were working okay. It's also an opportunity to look into the DVD drive again, which I might have incorrectly installed, as discs now struggle to go through the slot. So yes, I basically had to take it apart again, which was not fun. And the MacBook works totally fine. Everything is nice and clean and washed. A new SSD. The DVD drive is still a bit noisy. I don't know whether that's supposed to be normal. The fan is also still a bit noisy though. I've been running YouTube, and I guess in 2008 YouTube wasn't around, so that might be kind of a heavy task for this model. The speakers are also working totally fine, and it's nice to know that all the nasty corrosion on that motherboard is now gone. In the end, it was an easy fix. It was just a faulty fan and maybe some new thermal paste, but you know, I managed to break this thing, and we had to look into how to fix it. I guess I'll keep that in mind and maybe only use the engraver tool for something a bit bigger than all 4 or 2 components. So I hope you enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon, and the links are also down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, which is very much understandable, maybe you can buy me a coffee, and the link is also below in the description. If you don't want to buy me a coffee, which is also totally fine, well, I thank you for your time and I hope you enjoyed the video. I'm going to ship the MacBook back to Marco and Antonella, and that's it for today. I wish you a great day, and I hope to see you soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.